how do we solve for t in this equation? Well, first of all, let's discuss a few terms related to the equation. Number one, this is called an exponential equation because it's an equation involving exponents or powers or indices. In this case, the power or the index or exponent is t. The numbers 4 and 3 are called the base. So now how do we solve this? First of all, let's play around with the powers of 4 and 3. So we can write this as 4 raised to the power t, or raised to the power 2 over 2, minus 3 raised to the power t in brackets, or raised to the power 2 over 2, which of course is equal to 7. Now notice I haven't changed anything here because 2 over 2 is 1, and 4 raised to the power t raised to the power 1 is just 4 to the power t. The same applies to 3 to the power t. Right. Our next step now is to use the laws of indices. I'll write it like this. We know that if you have z to the power x brackets to the power y, this is equal to z to the power x y. In other words, I can bring the power outside the brackets inside the brackets. So in like manner, we can write this as 4 to the power t over 2 raised to the power 2. What I've done here is to bring the 2 at the bottom inside the brackets, because remember this is 2 over 2, so the 2 below, I've taken it inside. It becomes a t over 2. I can do the same here. That becomes 3 to the power t over 2 raised to the power 2 is equal to 7 as before. Now, secondly, let 4 to the power t over 2 equal to a, and 3 to the power t over 2 equal to b. So let 4 to the power t over 2 equal to a, and 3 to the power t over 2 equal to b. So our equation then becomes, this is now a, so it's a squared minus b squared is equal to 7. Now, doesn't this ring a bell? This, of course, is a difference of 2 squares. So we can factorize both sides of the equation as this is a plus b multiplied by a minus b is equal to, what are the factors of 7? Well, we only know 1 and 7 itself. So we can write this as 7 times 1. But notice something here. A plus b is obviously greater than a minus b on the left-hand side of our equation. And on the right-hand side, our 7, which is a factor of 7, of course, is greater than 1. So I've written the factors with the bigger one on the left and the smaller one after that. So this means that we can construct two simultaneous equations from the fact that this 7 here must be equal to a plus b, and this one here must be equal to a minus b. So we can write a plus b is equal to 7, and a minus b is equal to 1. These are our simultaneous equations. How do we solve that? Let's use the method of elimination. We add this here to that one to get 2a, b minus b is nothing, is equal to 7 plus 1, which is equal to 8. From this, it follows that our a is equal to 4. perform some back substitution. If a is equal to 4, we come back here, substitute for 4. So we have 4 plus b is equal to 7, meaning that b is equal to 7 minus 4, which is equal to 3. So a is equal to 4, b is equal to 3. But now let's go back to our assumptions. Yes, we said b is equal to 3 to the power t over 2. A is equal to 4 to the power 3 over t over 2. Let's take the first one. So we know that our a is 4. So we can write 4 to the power t over 2 is equal to our a, which is 4. Again, we can write the left-hand side as a4 to the power t bracket to the power a half. Remember, here we could take out our x in the same way there as we did the reverse. We can do the reverse of what we did here. We had this inside the bracket, so we can take the half outside the bracket. It's like we had z to the power xy is equal to z to the power x or raised to the power y. That's what I did here. So this is equal to, remember, it's equal to 4. Let's square both sides. We then have 4 to the power t is equal to 4 squared, which of course is 16. Now, on the right hand side, remember we said 2 here. My 2 is not nice. Let me write it a little bit more clearly. 4 is raised to the power 2, or the index here is 2. On the left hand side, the index here is t. Since we are using the same base, which is 4 on this side and 4 on that side, we can equate the indices. So t is equal to 2. So finally, we've got here our t is equal to 2 after equating the indices. Let's see if we get the same thing if we use the second equation here. 3 to the power t over 2 is equal to b. So we have 3 to the power t over 2 is equal to b. But what did we find b to be? b is equal to 3. So b is equal to 3. We can write this as before, as 3 to the power t raised to the power a half is equal to 3. Let's square both sides. We get 3 to the power t is equal to 3 squared. Again, the base is the same. It's 3 on both sides. So we can equate the powers. So therefore, this means that our t is equal to 2 as before. Till we'll see you next time. Thank you and bye-bye.